Hello Year 12 and welcome to our third video here for continuous probability density functions. Today I'm looking at the mean and variance of a distribution. So, we have calculated mean and variance for distributions before. We did these for discrete probability distributions. But now we want to look at continuous probability density functions. So when we did it for discrete probability distributions, to find the mean, multiply each value by the probability, add all of these together. Gives me the mean or expected value. For a continuous probability distribution, we've got to add an infinite number of products together, right? Because there's really an infinite number of values. It's continuous. But we get around this by integrating. So the mean or expected value is the integral from a to b of x multiplied by the function of x dx. For discrete probability distribution functions, to find the variance, we perhaps, and my preferred method, is not to do it this way, but this is one of the other ways to do it. Subtract the mean from each value, square it, multiply by the probability, add those together. That gives me the variance. Alternatively, we can, my preferred method, square each value, multiply by the probability, add these all together, subtract the square of the mean. Right, you're going to do fewer subtractions this way. Anyway, to make this relevant to our probability density functions, again, I've got an infinite number of tasks to do there, which I get around by integrating. So the variance, right, the variance of my continuous PDF integral from a to b of, I'm not going to do it this way, x minus mu squared multiplied by function x, because I end up with a slightly messier function to integrate, and integrating is often a tricky part of this process. So I would prefer generally to do this, is to square my, to multiply my PDF, right? Take my PDF, some function of x, and multiply it by x squared. Then integrate that and subtract the square of the mean. So I've still got to find the mean, right? To find the variance, I'm going to have to do some other integral to find the mean and use that in this calculation for either method. And standard deviation is the square root of the variance. No tricky things to do there. Here's an example. First of all, show that this function, x over 8, is a valid probability density function where x is between 0 and 4. Then find the mean and standard deviation. How do I show that it's a valid probability density function? To do this, remember, two conditions. Always positive, and the integral over the domain has to equal 1. So, my function, x over 8, as long as x is not negative, then that function is not negative. It can be 0, and I said from 0 to 4, strictly greater than 0, but I'm going to say, actually, I'm going to amend that, and I'm going to say from x is greater than or equal to 0, and less than or equal to 4. I'm going to go with the equal to. Over that domain, my function is never negative, so that's the first condition. My second condition is the integral of that function over the domain from 0 to 4 has to be equal to 1. So we integrate x over 8, and I get x squared on 16. And substituting 4 into that, I get 1. Substitute 0, I get 0. Difference of 1. There we go. There's my two conditions that show that function x equals x over 8 is a valid probability density function over the domain 0 to 4. Second thing, find the mean. So the mean, we take our function, x over 8, and multiply it by x. We integrate that from 0 to 4. So the when I multiply that, I get x squared over 8. Then I integrate that, and I get x cubed on 24. Evaluate that over the domain 0 to 4, or between those bounds, I get 8 over 3. So my mean of that function is 8 over 3, or 2 2/3. That's good. It's within my my range of values, somewhere between 0 and 4. Nice. 8 over 3, reasonably confident that's working out. Now, to find the standard deviation, I have to find the variance first. And to find the variance, I'm going to take my function, multiply it by x squared, then integrate that, and subtract the square of the mean. So, the integral of x cubed over 8 is x to the 4 on 32. The square of my mean is 64 over 9. Right, evaluate that, and I get 8 over 9. So my variance is 8 over 9. And what I'm asked to find is the standard deviation. The standard deviation is the square root of the variance. So the square root of 8 over the square root of 9 is 2 root 2 over 3. And that's just slipped off the bottom of the screen a little bit there, I think. Creep up a little bit there, that's a bit better. 2 root 2 over 3 is my standard deviation. Right, so we're asked to do 3 things. Show it's a valid probability density function. And we check those 2 conditions. Always positive, has the integral is equal to 1. Find the mean, multiply my function by x, then integrate it. Find the standard deviation, multiply my function by x squared, integrate, subtract the square of the mean, and then take the square root. Righto, met all those conditions for the question. That was, whoops, now I've fallen off the top of the screen. That was mean and variance of a continuous probability density function. So we tested that, it's always positive, and the integral over the domain is equal to 1. The mean is the integral of x multiplied by the function. The variance, x squared multiplied by the function, and then subtract the square of the mean. And the standard deviation is square root of the variance. Rightio. Any questions? Let me know. Otherwise, I'll see you next time for the standard normal distribution. Thanks, guys. See you next time.